Tracking your phone's location is critical for a wide variety of apps, from ride-sharing to social networks to shopping. In this episode, we'll break down the technologies that are used to track your phone's location. Welcome to Kopec Explains Software, the podcast where we make computing intelligible. So Rebecca, this week we're going to talk about how your phone's location is tracked.
Let's start with going through the different technologies that can be used to identify a phone's location.
Yeah, so the first thing that distinguishes your phone and makes it different from other computing devices is, of course, that it connects to a cellular network. For example, I'm on T-Mobile, so I connect to the T-Mobile network. Every time my phone is on, it's pinging their towers. And we can actually use those pings to those towers to triangulate where the phone is. How strong is the signal of the phone to a particular tower? If I actually have 3 towers, we can very precisely tell where the phone is. It might have a really strong signal to one of them, it might have a less strong signal to another, and it might have a different kind of signal to the third. Between those 3 signals, it's possible to plot on a map exactly where the phone is relative to those 3 towers, because we know approximately the distance from the tower that is required for a certain level of strength of signal. So triangulation using cell towers is actually a pretty precise way to figure out where your phone is.
What's the next technology?
Another technology is, of course, GPS chips. GPS chips are quite different than cell tower triangulation. Instead of connecting to towers, we actually connect to a satellite. Now, the GPS system is actually run by the US government, the US military to be precise. And in the late 1990s, under the Clinton administration, it was made into a public good, so something that commercial technology companies could take advantage of. If your phone has a GPS chip, which basically every phone does today, it can actually directly connect to a satellite, get a satellite signal, and find out within 10 meters where it is. That's a nice level of precision. It might surprise you to know that the first iPhone actually didn't even have a GPS chip. The GPS chip was added in the iPhone 3G. This enabled more precise navigation apps. Can we imagine having our phone today without Google Maps or Apple Maps working really well? Well, GPS chips have really enabled that. So GPS technology allows a great level of precision, but there is one downside.
Yeah, it doesn't work well indoors.
That's right, or even on a very cloudy day, it's possible to not be able to get that good satellite reception. So the trade-off with GPS is that it's really accurate, but it's reliant on connecting to a satellite, which is not always possible, and it actually uses quite a bit of battery power, and that's something we're going to come back to a little bit later.
And then the last technology is actually using Wi-Fi databases.
Yes, so all the time as you're moving around with your phone, you're surreptitiously pinging different Wi-Fi base stations. And Apple and Google actually maintain databases with where all of these Wi-Fi base stations are. And maybe that's a little bit creepy to you, but it just so happens that somebody happens to have some Wi-Fi base station in their house. As you're driving, you go by that Wi-Fi base station, and Google happens to know that that house is located in some certain place, and therefore the Wi-Fi base station is in that certain place. And so it can tell exactly where you were because you went by that Wi-Fi base station and pinged it. Now, that doesn't mean that you actually connected to that Wi-Fi network. Just seeing that the Wi-Fi network is available, and again, like with the cell phone triangulation, how strong your signal is to that base station can actually tell us approximately where you are if we have this big database of where all these Wi-Fi base stations are.
A technology that used to be used a lot was IP addresses. Is that right?
Yeah, so there's an even rougher way of trying to figure out where somebody is, and that's just based on your IP addresses. So IP addresses are actually assigned regionally. So for example, just based on your IP address, I could maybe tell if you're in the United States versus in Canada. It used to be even more granular than that, but today so many people are using VPNs or virtual private networks or having some other way of hiding their IP address that we can't really rely on this. And it never was super precise, but what IP addresses still can give us a general sense and a way of maybe telling what general big area somebody is in, but we wouldn't use them for something like a navigation app.
No, now they're really used for exclusion. So you can't use an app or access the same things in a specific country or area or something like that.
That's right. So that's why sometimes people are in a different country and they connect through a VPN in order to access services that are excluded from that country. Let me give you an example. If you're using Netflix and you travel to Canada, while you're in Canada, it'll see your IP address is a Canadian IP address and it'll start offering you Canadian Netflix. And that Canadian Netflix has different shows than American Netflix does. So some people use a VPN to connect back to the States that they can look to Netflix as if they're in the States and therefore watch American Netflix. But yes, it's not a technology we would use for tracking your location very precisely. It's for giving us very broad strokes about what region you're in.
So as a developer, do you just get to decide which technology you're going to use for your location tracking?
Both Apple and Google have APIs that enable a developer to request the user's location. When you request the user's location, you can also specify a frequency of updates, how often do you need the user's location to be updated, and how precise you need the user's location to be. Now you might wonder, wouldn't you just want as frequent updates as possible, as precise as possible? Not necessarily, because there's a trade-off here between battery consumption and accuracy and frequency. The more frequently that you request the user's location, the more battery life you're going to use. All these different chips that we talked about, the cell chip for connecting to the cell tower, the GPS chip for connecting to the GPS satellite, and even the Wi-Fi chip for connecting to a Wi-Fi base station or pinging one, uses battery power. And they use different degrees of battery power. And so if you don't need really that location for very long, then you shouldn't be using up all that battery power using all these chips. And these different kinds of ways of finding location also offer different levels of precision. For example, the GPS offers a lot of precision, but it also uses a lot of battery power. So maybe we don't always need it. And if we don't always need it, then we shouldn't always use it. Because as an app developer, we don't want to be a bad guest on the user's phone, writing an app that's going to take up all of their battery power. And so we need to be judicious about our use of these technologies. And Apple and Google try to make this a little bit easier by making APIs that automatically decide for us in the background which of these technologies to use based on the level of precision and the level of frequency that we need updates.
The user also has to accept location services, correct?
That's right. This is a privacy concern. If you go back to the very early days of iOS and Android, there weren't even these pop-ups that would come up and say, hey, are you going to let this app track your location? And some apps were surreptitiously tracking the user's location. You might say, why do they want to do that? Well, they could potentially sell that data to advertisers. This continues to be a big battlefield, and there are some apps that are really using your location for nefarious purposes. And so my default is to always deny, unless it's an app that I know specifically it's going to use my location for a purpose that I'm comfortable with. My default is no, I don't let apps use my location. It's a danger to my privacy, and it's also a danger to my battery.
Wait a minute, what about tracking indoors?
Yeah, we've been mainly talking about technologies that work well outdoors. So we talked about GPS, we talked about how that doesn't work indoors. Now, when you're indoors, you can still, of course, track by Wi-Fi, and you can track by cell tower, but it's not generally going to be as precise as GPS. But there is another way to track you indoors. While GPS stands for Global Positioning System, there is also the concept of an Indoor Positioning System, an IPS. One of these is known as iBeacon, which has been developed by Apple since 2013. Here's the idea. You have a bunch of little devices that as you walk around a big building, your phone pings. So it's kind of like pinging those cell towers or pinging those Wi-Fi base stations, but instead these are really small, really low energy devices that are placed throughout a building at known locations. So you walk through the floor of a building, and as you traverse the hallways, there are these little iBeacons, in the case of Apple's system, that are maybe taped to the wall somewhere. Hopefully they're screwed in, actually, to the wall somewhere, or maybe they're hidden in the wall or hidden in the rafters or something like that. And we know exactly where all those iBeacons are. So as you pass by them and you get a little signal from your phone to them, maybe over Bluetooth low energy, we know exactly where you are relative to them. And again, if there's multiple of them that we get a signal to, we can again triangulate where you might be. So this requires a lot of investment on the part of the building owner. The building owner has to go and actually build out all of these beacons throughout their building. And that can be quite expensive, and that can be something that's really not necessary unless you're in a field that would really benefit from indoor positioning. Let me give you an example. Maybe it's a huge warehouse store or a huge supermarket, and you want your customers to very precisely be able to see where they are as they travel to a very specific aisle through your app.
Or an airport.
Or maybe you're an airport, absolutely. Those are scenarios where having this level of investment might be worth it. But most of the time, we're in smaller buildings and buildings that don't really require sophisticated traversal. And so building out something like this doesn't really make sense. So we don't see a lot of indoor positioning systems yet. They have been rolled out in certain commercial applications. Very rarely does anyone have any interest in doing them in their homes, although I have seen some consumer-friendly products in this space.
So overall, tracking your location requires the combination of several different technologies that are all working together and doing different kinds of trade-offs at different points.
Right. They offer different levels of precision versus battery versus convenience. For example, we talked about GPS not working indoors, using a lot of battery, but being very precise. We talked about pinging Wi-Fi, working anywhere, but not necessarily being as precise and depending on this kind of private database that Apple and Google need to maintain. So there's a lot of trade-offs between all of these technologies. What they all have in common, though, is being tracked is a threat to your battery life of your phone and also your privacy. And so I think everyone should remember that the next time that they open an app and get asked, do you want to have your location tracked by this app? Your default should probably be no if you care about your battery life and your privacy. Thanks for listening to us this week. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
We'll see you in 2 weeks.
Bye.